Good morning. My name is Venkat Venamala. Today my topic is on failure detection algorithms in overlay networks. Agenda: Introduction, problem solutions, related work, and conclusion. Coming to introduction, overlay networks have rapidly increased to deploy new applications and services in the internet. One of the main reasons overlay networks acting as excellent platform for large-scale distributed systems is their resilience in the presence of node failures. This resilience relies on exact and timely detection of node failures. Peer-to-peer is defined as a class of applications that take advantage of things such as resources, storage, cycles, content, human presence available at the edges of the internet. In overlay networks, neighbor nodes are defined by content stored. Problems and solution. Design of various keep alive approaches affect node failure detection time, control overhead, and so on. By comparing five distributed failure detectors, we know nodes can reduce average delay between failure occurrence and sharing information. The solution is maintenance of back pointer state among the class of keep alive algorithms, improved detection time, and packet loss rate. Resilient overlay networks. These type of overlay networks calculate all the links between each nodes. They detect and recover failure within seconds. By using this, we can find the error node easily. Overlay networks calculate all the path properties. These resilient overlay networks decide the best path to be used for the applications. They divert the traffic over that way. These are some of the keep alive techniques which are used on detecting the failure of the nodes. Baseline. In baseline, decision is made by the node independently about its neighbor. Every node sends to each of its neighbor a ping message for every delta seconds. Um, Baseline is intuitive and very easy to implement. The figure shows that the each two there are two nodes and it sends a ping message and an acknowledgement is received. This is another type of keep alive technique. It's the sharing negative information. In the same thing happens here as the baseline. Every node sends a probe to all its neighbor in delta second and wait for the acknowledgement. When the node faces a number of consecutive timeouts to its neighbor, a boost message is sent to its neighbor by the node. If you see the nodes A and C, then a boost message is sent to the node C because A and F are sending the nodes to each A and F are sending the node to its neighbors, and there is an A and F faces a number of consecutive timeouts, so a boost message is sent to its neighbor by the node. Sharing negative information with the back pointer. Each node sends a probe to all other nodes in delta second and wait for the acknowledgement. If a node experiences some consecutive timeouts to each other node, then it sends negative information to all other nodes. The same thing as the previous slide, but here it sends the negative information to all other nodes. The related work. Failure detection is performed in link layer at hardware level in routing protocol. Information shared at variety of algorithm to keep maintained state. Gossip style of failure detection. Liveliness of other node by the node gossip style. One hop and two hop lookup schemes by the Gupta to disseminated changes of membership. Disseminating node failures have alternative with the back pointer state in the sharing algorithm. Bandwidth requirements are depending on the Mbps range number of nodes in the system. Conclusion. In this paper, we concentrate on the execution of an assortment of keep alive calculations that vary in the measure of the data shared. We create schematic models and users to concentrate on the execution of these calculations, utilizing the measurements of identification time. At long last, sharing of data permits the system to endure a higher PAL rate than the pattern calculation. These are some of the references I have used, and thank you.